Now let's look into the question that is given. The question that is given, it is in a form of a practical work. Why is it in a form of a practical work? Because we are expected to do a practical on conservation of linear momentum, where we will be using two trolleys of an unknown mass, whether to determine that momentum is conserved or not. So this question, it was an exam question, but based on the practical aspect of conservation of linear momentum. Ladies and gentlemen, let's read the question. Trolley X with mass M. So they are not giving us the mass. So let me just write down data to say for X we have M, which is the mass, which is just m kg, is placed against trolley Y with mass 3m. Then you have Y with mass 3m kg. They are not giving us now any values relating to this information, but we just know that the mass of Y is 3 times more than the mass of M. Now, can we get the data initially? Yes, now it says here, a compressed spring between the two trolleys releases in 0.3 seconds and the trolley moves in opposite directions. Now let's check. The table below gives the position of trolley X for the interval of 0.3 seconds. So it means Y will move into this direction and then X will move into this direction. But because we are working with a vector quantity, what must be done? It is that we must say choice of direction. So we are going to choose plus S to the right and then automatically minus to the left. Now one should be asking themselves, how many objects do we have? Ladies and gentlemen, it is clear we have two objects. And we said once we have two objects, we are expected now to use or apply conservation of linear momentum. So these are just basic hints that I think if each and every one of us can be able to use them, believe you me, we will be in a right position of getting everything right. We are still analyzing the data that is given. We are still analyzing the data that is given. Let me do this. We are still analyzing the data that is given. We have not attempted the question already. Then let's interpret the table that has been given. Let me get a highlighter and say at position 0, time is 0. Position 0 means what? Both trolley X and Y are stationary. So I can extend my data and say from this information V initial of X is 0 meters per second. V initial of Y is also 0 meters per second. How do I know that? at position 0, time is 0. And if you remember well, in grade 10, we said we can calculate speed by using the equation distance over time. So what does this say to me? It says examiners can easily incorporate the concepts of grade 10, 11, and 12. Let's be now on the lookout for that. But something is happening when I interpret this particular graph. The distance covered by x is moving from 1,38, 2,88, 4,38, 5,88, but at this point here, the distance is remaining to become the same. It is now what? 7,38, 7,38, 7,28. But what is this saying to me? It says now x, it has reached the barrier and it is no longer moving forward because the distance is no longer changing, or the position is no longer changing. If the position was to change, if it was moving, it will move 7, 4, 3, 7, 5, 8, 7, 5, 9 to show that it is still in motion. But in this instance, it is not in motion because 738, 738, 738, it means the same position. It means the same position. And I wish to say, please, when you get questions, don't attempt the questions without analyzing the question itself, because analyzing the question is what will give you a better understanding of what is expected from the question. Now let's check. At which time t does trolley x hit the barrier? We are now at 4.1. We have said it is hitting it at 1,5 seconds. Because from 1.5 seconds, it's no longer moving any direction or change in the position itself. 4.2, explain with the reference to the values in the table why trolley x moves with a constant speed between t 0,3 and t 1,5. Let's check what is happening at 1,5. At 1,5, we have the position of 7,38. At 1.8, 7,38, 2.1, 7,38. What does this say? It says now, if I were to calculate the speed is equals to distance over time, and this is just 7,38 divided by 1.5. And because of that, ladies and gentlemen, the expectation is, because the position is not changing but time is changing, 0.38 divided by 1,5. This gives us 4,92 meters per second. Now let's understand the concept of constant speed. Constant speed means the position is not changing but however time is increasing. So we can basically just say from the above calculation we can explain that between 0.3 to 1.5 seconds, if maybe we're also to calculate speed at let's calculate speed is equals to distance over time, but now I am going to use a value that is less than that. Let's use 5.88 divided by 1.2. Let's check the answer thereof. 5.88 divided by 1.2. It is giving us now 4.9 meters per second. So between 0.3 seconds to 1.5, the speed remains the same, or we can say it remains constant. We have proved that this is now at 1.5 and this is now at 1.2 seconds. So maybe you are not forced to be using this coordinates that I chose. Let's take the 0.3. 1.38 divided by 0.3. It gives you 4.6. It's when now it's starting to pick up. Let's check if the 2.88 divided by 0.6, 2.88 divided by 0.6 is giving us 4.8. So it basically showing that as it moves, there's a point now between 0.9 as well as now 1.5 where it is going to give us the 4.92 meters per second. So this is a way of indicating or proving that it is actually doing what? It is actually moving at a constant speed. Your Excellency, questions please.
So it's like for me now, it's like if I saw that question, I would have said that it's moving at a constant it's moving at a constant speed because there's no friction or something similar to that.
Because there's no
I,
friction.
like I didn't know that like you would have to like prove that it's moving at a constant speed.
Okay, I think we can add that to say also because there's no friction, but maybe it will be the best answer. I want to agree with you. It will be the best answer if we're told that in an isolated system, something like that, then that will be a clear confirmation that indeed there is no friction. That is the reason why it is traveling at a constant speed. But because they did not say that, I'm afraid to accept it. But when we do the practical, we always try to say frictionless surface, frictionless surface. So maybe we can add it as an option to say because there is no friction. But this reason, ladies and gentlemen, it will be 100,000% correct, provided that your excellency we are told something about frictionless surface or something about isolated system, because we will know that there are no external forces, or the learners that are now doing this experiment, they are using a petroleum jelly or Vaseline to reduce the amount of friction, something like that. But in this instance it's not said, hence I'm going to say I partially accept this particular answer. But however, it is not wrong, because when we do the experiment to prove the conservation of linear momentum, we say it must be isolated system, then it means there should not be any friction. So, but because the question itself did not say anything about that, it is the problem of the examiners. But I can partially accept that answer. Lwandle, inputs, suggestions, questions, please.
No, sir. I'm good for now. Thank you.
Thank you very much. Then, ladies and gentlemen, let's move. 4.3, state the principle of conservation of linear momentum. The total linear momentum of an isolated system is conserved. 2 or 0, nothing in between. 2 or 0. Now remember that analogy that I tried to explain, that says state, use and apply. State, use and apply. This analogy says the examiners said I must state, so immediately after stating I must use the principle. That is how I can try to also cheat the examiner, because the examiner will always give me a guide, a way of saying what is it that you can use. So the fact that state, use and apply is one analogy that I also developed for myself. It means the question that will follow, 4.4, what must I do? I must apply the conservation of linear momentum. What does the conservation of linear momentum say? The conservation of linear momentum says the sum of the momentum before 4.4, I'm just going to try and squeeze it in here. 4.4, the sum of momentum before is equals to the sum of momentum after. By just doing that, I'm in a position of getting everything right. Why? Because I am also given a step ahead by what? By working with two objects. Once there are two objects, I must now apply what? Conservation of linear momentum. So that on its own, it is a bonus. It is a confirmation of what? State, use and apply. So already I know I have two objects, but this two object is m of x v initial plus m of y v initial, and this, ladies and gentlemen, we agreed that this is before, and we know that we are going to have m of x v final. We are also going to have m of y v final, and this is after. Now what do we know? We know that v initial is going to be 0, so I'm going to have 0 plus 0. Do we agree? Because also the v initial of y, it's now 0. But in actual essence, ladies and gentlemen, this thing here, NB, we agree it is an explosion. So it is one type of problems that we agreed. It is an explosion. So for explosion, we said the sum of momentum before is equals to 0 kg meters per second. We agreed and we were aware of that. VC, questions please. Bonolo, inputs, suggestions?
Sir, no questions from my side. I'm still fine.
Thank you very much. Now let's move. What is the mass of X? It is just m. What is the velocity final? We calculated it at 4.2. It is 4.92. But now to the left, then it must be negative there. Plus, what is the mass of Y? It is 3m. What is the velocity of V final for Y? That is the question. Calculate the speed of trolley Y. So we want to say V final. So what is happening here, ladies and gentlemen? I'm going to have 4,92m, which is equals to 3m V final. So I'm just going to divide by 3m, divide again by 3m. Then it's easy to see that the m will cancel the m, and then let me maybe take it up here. Okay, sorry, let's take it up here. V final for Y is now just equals to let's do the calculation. 4,92 divided by 3 is equals to 1,6 meters per second, and to the right, and this is now our answer. Excellency, questions please.
Oh, no, I'm still good, sir.
Thank you very much. Landle, questions please.
I'm also still okay, sir.
Thank you very much. So the issue of 3m and m did not confuse anyone. I just want to confirm, because what I've seen in the previous years, people will substitute m with 1, and then they will say m is equals to 1, and then everywhere where they see m they substitute 1, and that is not the right mathematics, rather the right science as well. So those that are with Mr. Mbodle with the mathematics, he will explain this in detail. Now we have done this one, ladies and gentlemen. Let me give you your 50 seconds digestion of everything we have done, and then we can continue with this particular question. Thank you very much. Let's look into it, ladies and gentlemen. In a physics laboratory, a trolley of unknown mass m moves along the track at a constant velocity of 0.4 meters per second. A wooden block of mass 500 grams is released directly above it and lands on top of the trolley. First thing first, how many objects? 2. We agree. 2 objects. So the chances of conservation of linear momentum, very high. But let's look into the question. The trolley along with the block continues moving at 0.15. Now let's write what is happening after. We have V final for the block and the trolley, or maybe I must use TB. The trolley and the block is now one system because they are moving together, which is just 0.15 meters per second. But the block is released. V initial of the block is 0 meters per second. However, we know that this one is moving. V initial of the trolley is 0.4 meters per second. That is the information that is given. We also have the mass here of the block, which is 500 grams, and our mass in physical sciences must be in kg, so m is equals to 0.5 kg. Now define the term momentum in physics. Very easy definition. Very easy definition. It says momentum is the product of mass and velocity of an object. Two marks. 2 or 0. 4.2. Is this collision between the wooden block and the trolley elastic or inelastic? Is it elastic or inelastic? Let's maybe go to the previous notes. How can one prove that it is inelastic or it is elastic? It's very easy. If the sum of the kinetic energy before is equals to the sum of the kinetic energy after, that collision is elastic. If the sum of the kinetic energy before is not equals to the sum of the kinetic energy after, then that collision is inelastic. However, we have a problem here. We have a trolley with an unknown mass, because let me quickly write it here. The sum of EK before will be half m of the trolley v squared of the trolley initial plus half mv squared of the block v squared initial of the block. So can we already see that if I do not have the mass of the trolley as an unknown, I will not be able to complete this particular calculation. Then it means, what must I do? I must maybe use conservation of linear momentum. And why? Because I said it there, Bonolo and Lwandle, to say, but I have two objects. So the chances of me using conservation of linear momentum are very, very, very high. I need the kinetic energy, the sum of the kinetic energy before and the sum of kinetic energy after, for me to actually prove that a collision is elastic or inelastic. Very, very, very important. But I will not be able to get a value because I already know that, but I don't have the mass of the trolley. So what can I do? Sum of momentum before is equals to the sum of momentum after. Conservation of what? Conservation of linear momentum. And this is easy. Before, they are moving in the same direction. M of trolley, V of trolley plus M of block and V of block. M of block, V of block. This is now initial. What's happening after? They are moving together. M of block plus M of trolley, but they have now the same velocity of 0, of TB. Now they have this particular information. So let's start. We don't know MT, but we know it was moving at 0, 4. We know the mass of the block, it was 0, 5, but initially it was released, it is 0. We know the mass of the block is 0, 5. We don't know the mass of MT, but we know that it was moving now at 0, 15. Now I must perform the mathematics here. The mathematics says this will be 0, then here I will have 0, 4 MT, which is equals to 0.5 multiplied by 1.5. Let's get the calculator. Zero comma 5 multiplied by 0.15 gives us something like 0.075 multiply by 0.15 MT. Allow me to remove this. We will go back to it because it was for the purpose of explanation. Then can I group the like terms here? Yes, I can. I can say 0.4 MT minus 0.15 MT is just equals to 0.075. Then the mathematics allows me to say 0.4 minus 0.15. This will just give me 0.25 MT 0,075 divide by 0,25 divide by 0,25. They cancel. Then mass of the trolley 0,075 divided by 0,25. The mass of the trolley is 0,3 kg. Now I have the mass of the trolley. I am not worried about any unknown. Then I must say the sum of EK before is equals to the half mv squared of the trolley plus half mv squared of the block. Then this is just half of 0,3 squared. We know it was moving at 0,4 squared plus half of now the block 0,5, but initially it was released 0 squared. Then I'm going to get my answer in joules, and I know that everything multiplied by 0 is 0, so I can easily say 0,4 multiplied by 0,4 multiplied by 0,3 divided by 2. It gives me something like 0,096 joules. So this is now what? The sum of the kinetic energy before. Do I need the sum of the kinetic energy after? 100%. The sum of EK after is just half of m of the trolley, v of the trolley, plus half mv squared of now what? Of the block. But there's something common here. V of the trolley squared plus half m b of the block, v of the block squared. There's something common here. Half of 0,3 kg. They are moving together, so they have now what? The same velocity. The velocity of the trolley is the same velocity of the block. Why? Because, ladies and gentlemen, they are moving together. 0,15 squared plus half of 0,5 and then 0,15 squared. Then we can calculate what is happening here. We start by saying 0,15 multiplied by 0,15 multiplied by 0,3 divided by 2. It gives us something like 0,003375 plus, ladies and gentlemen, 0,15 multiplied by 0,15 multiplied by 0,5 divided by 2. Then gives us 0,005625. Then plus 0,003375. And then it gives us an answer which is 0,009 joules. Now, let's compare these two answers. The other one is 0,096, the other one is 0,0096. So what does this say? It says the sum of EK before is not equal to the sum of EK after. Therefore, because of that, this collision is inelastic. Or the other reason, if you don't want to use that, you can say energy, total energy, total kinetic energy is not conserved. You can basically and easily say that. So this is some of the questions that I know and feel that the examiners will always be asking it. Prove whether the collision is elastic or inelastic. The only way of doing that, you cannot compare the momentum, but you can only compare the sum of the kinetic energy before and the sum of the kinetic energy after. Let's go back to this nice summary of the collisions. I was explaining here to say momentum in elastic collision is conserved. In inelastic collision also, momentum is conserved. The only way of us proving that collision is elastic or the collision is inelastic is if we can prove that the total kinetic energy is conserved. By doing what? By calculating the sum of the kinetic energy before, and if it is equals to the sum of the kinetic energy after, then that collision must be elastic. If the collision we calculate that the sum of the kinetic energy before is not equals to the total kinetic energy after, we say that collision is inelastic collision. So you cannot prove with momentum, but you can only prove with now what? With the conservation of kinetic energy. So that is exactly what we have done. We calculated EK before and we calculated EK after, and indeed they are not equal. And the fact that they are not equal, then it means the collision must be inelastic. Your Excellency, questions, inputs, suggestions, please.
I'm still okay.
Thank you very much. Luandle?
Yes, sir, I'm still okay. I got a little bit lost some places, but I caught up again. I'm still okay.
Okay, no. Thank you very much. Bonolo? Okay. Tumelo, we lost you some time back. Are you trying maybe to follow the basics that I just explained?
Yes, I had already done this activity yesterday. I thought it was one of the activities that we had for homework.
It
I
was. It was.
yes. So I did the activity. I also got I also proved that it was inelastic, but my answer is not the same as my answers aren't the same as yours.
Which mass maybe did you use for the trolley? Let's maybe start there.
For the trolley, I used let me see. No, for the trolley, for the initial, I used M.
Yes, so the answers are going to be different because of you did not now calculate. It means you have your final answers in terms of M, because M is given as an unknown. You understand?
Yes, but I calculated M, and I got 0,0768 kilograms, but I'm not sure. Maybe I did it wrong.
It's just maybe an issue of the mathematics. Kindly send it to me. Let me scrutinize it and then I can pick up your problem somewhere.
Yes, sir.
Thank you very much. It was part of the homework activities, hence I usually say please do them such that when you discuss, it's easy for you to pick up the challenges that you might have. Then we know that the remedial part of the things is actually working well. Ladies and gentlemen, let's go to 4.3. Draw the velocity versus time sketch to illustrate the motion of the trolley before and after. No values needed. This one is easy. I'm just going to squeeze it in here. No value needed. It goes something like this, and it comes down, and something like this. Why something like that? Velocity, time. Why something like that? Ladies and gentlemen, it did not change the direction. It kept on moving into the same direction. If it changed the direction, we will have something like this. So, Your Excellency, I got your answers. Let me just confirm again. Nyakalo, yes. 100% done, because it did not change now the direction. We can easily just say fine, we have here 0.15 meters per second, and then here it started now with 0.4, and that is basically it for just easy 2 marks. Ladies and gentlemen, it is exactly 1857. I will just like to request Nyakalo give us the reflection of the day, because like I said, majority of the people are not here, so let's not open too much gap so that they can easily be able also to recover, because anyhow I feel that we are right on par but a little bit behind. However, it is important to understand these particular concepts. Your Excellency, reflections of today's lesson, please.
Sir, I enjoyed today's lesson. It was really fun just going through the work, finding out where I would have went wrong, depending on like different questions. I really enjoyed like today's session. Thank you, sir.
Thank you very much. Levezi.
No, so it was a really good session, and I like that we did exam questions because they're not like as easy as the ones that we see in the textbook. So we get more like of an idea of what's actually going to be asked. So it was really good.
Thank you very much. But remember, when I say homework activity, please do it and send it. Because homework activity, ladies and gentlemen, remember, we don't meet day in, day out, or week in, or the whole week as if you are going to meet with your teachers. So the only thing, or the only time where I can get feedback and impact is if you at least attempt to do the homework. I will not mark it, I will look into it. I usually say I will look into it. I will look into it definitely. Hence, I could easily see that Mr. Nyoko did the graph 100% correct because the answers I received. So that also motivates me to say that at least we are starting to understand most important critical concepts. So, ladies and gentlemen, for Friday, we do this one, number 1, and then this one, number 2. If you have done it, not a problem, just kindly send me your answers and then we will be able to discuss. Ladies and gentlemen, it is exactly 1900. Let's meet Friday 1800 to 1930. Thank you very much and have a lovely day.